At 9 a.m., a pump was turned on in order to add water to a holding tank. If R of t gallons per minute is the rate at which the water is being pumped into the tank, where t is time in minutes since the pump was first turned on, find an integral that represents a number of gallons of water that was pumped into the tank for the hour from 10 o'clock to 11 a.m. So there's all kinds of things to think about here. 9 a.m., the pump was turned on. Okay, so that means that my initial t happened at 9 a.m. So in other words, when t equals 0, it's 9 a.m. And it says the water is added to a holding tank. R of t is gallons per minute. R of t, unit of measure, is gallons per minute. That's nice to know. And t is time in minutes. T is minutes. Now we're supposed to find an integral that represents a number of gallons of water pumped into the tank. So I know that if I have my rate, R of t, and I multiply it times a portion of t, that's going to give me gallon per minute times minute, which is gallons. And that's what it says there. It says we want to find an integral that represents a number of gallons of water. So using my units of measure with what I have, I know that if I multiply these two things together for some small fragment of t, I actually get the gallons that I want. Now, if I add up all of those R of t dt's, you know, where delta t gets really small and goes towards infinity, I need to add up for the time interval in question. Now, when t equals 0, it's 9 a.m. So what time is it? When t is in minutes, remember, what time is it at 10 o'clock? Well, that's 60. And then what time is it at 11 a.m.? Well, that's another 60 minutes, so it goes to 120. So these kinds of problems, you have to think carefully about everything you have. Look at the units of measure. That's the key, units of measure. And there's your integral that represents a number of gallons of water.